So I'm going to show you how to solve for example 18. Let's look to the question. Determine if the following integral converge or diverge. If the integral converge, determine its value. Okay, we have two parts, part A and part B. So let's solve one by one. Before we can proceed to the integral, we must first remove the discontinuity, as we know that we cannot do the integral as long as that discontinuity exists. As a result, we must first eliminate the discontinuity. Okay, we have to integrate the integral given by the question. So by using the formula, we have to substitute the value that we get from the integration of the integral. So we will get the value of negative 3 to the power of 5 over 3. So the limit was finite and the integral is converged. So as before, we must first remove the discontinuity. Okay, now we do for the part B. First, notice that there is a division by zero issue in the integrand at z equal to 5, which is the lower limit of integration. The limits on the integrals are then taken care of by evaluating the limit in the integral. As the integration interval is entirely on the right side of the lower limit, we must use a right-hand limit in this case. Then we will continue to evaluate the given integral. Then we take out the constant from the integral and then we will get 1 over 2. And then I let 10 plus 2z equal to u. So we will get 1 over 2 ln u. Then substitute the value of u, which is 10 plus 2z. Then 1 over 2 ln 10 plus 2z plus c. And then we settle the right hand limit. And then we substitute the value of the integral that we get from the integration of those integral. 1 over 2 ln 10 plus 2z. Then 1/2 ln 12 plus infinity, and then we'll get infinity. So since the limit was infinity, the integral is divergent.